That's right.
Data center. I'm trying to pronounce it as a Giphy is easy because it rolls off the tongue. DCFEE. The data center for everywhere else, which is what's up next, does not come easily off the tongue.
No, it doesn't.
But in any case, I'll bring our next folks in. I think we have Christopher and good afternoon, good evening, good morning, sirs.
Good morning, at least here for some value of morning. And I'm not sure, sir, but I'll take it.
I suppose the whole order of the British Empire has not been bestowed upon on everyone, so we could just be data center friends.
All right. Well, thank you. I was listening into the end of the last talk. It was pretty interesting and entertaining. So hopefully we'll not disappoint this time around. Doesn't get excited about talking about things like TDP and cooling.
You come across a bit of that in your day to day, I suppose. Introduction wise, Christopher, who's chief architect of cloud at Cisco. And Patrick, who is the editor-in-chief at Serve the Home. But you may be muted. I don't think you're muted in the StreamYard, but I'm not getting any audio from Patrick.
Unless you're doing a miming performance, and then this is spectacular.
Is this any better?
That's much better.
Yes. I don't know, Patrick. At least we can hear you. Let's put it that way. I don't know if that's better or not, but we can at least hear you.
Yeah, I don't know if this is an upgrade at all. Anyway, hey, I really apologize about that, guys. I have like 4 inputs, and Comcast decided that it was going to stop working this morning. So we're doing a little shuffle this morning. Hey, thanks for the introduction. Do you want me to share just kind of some slides that I think Christopher and I went over yesterday?
I believe as soon as we bring Matt in, I think we have one more for our.
Okay.
That's the cue.
Hello. Excellent. Matt is in. He's director of cloud at NVIDIA, and we've broken the ice with no one. I suppose broken the ice with awkwardness with both audio issues and AV trickery. But I think that's the order of the day when doing anything remote conference-wise. Final random question before we kick into data center for everyone else is, if you were to give a talk that wasn't this one on a non-technical topic, what would you be excited to talk about? Christopher first.
Oh, wow. I don't know. You stumped me on that one. I guess let's call it landscape photography with medium format film cameras. Something along those lines. That might be an interesting one to do. For those of you who remember, who are old enough to remember that not all cameras have always been digital, but some actually used chemistry at one point in time.
Still highly technical, but not digital. I like it. Patrick?
Analog, baby.
Cool, yeah. So I think if I had to give a talk that was non-technical, but potentially still talked about technology, probably what I have a big passion around in terms of something that we're doing on STH this year, and hopefully can do more of starting later this year, is really kind of figuring out ways to highlight stories and bring attention to the fact that there is a giant digital divide. Just the fact that we live in the US, we have a lot more access to technology than a lot of other folks, which provides opportunity. And so it is something that, we are starting to do some video content on and do kind of regular series on, in terms of, really highlighting folks that are in the technical community that are bringing out, I would say a lot of their expertise and I guess the benefits of their knowledge and experiences to other communities out in the world. So that's something that we're going to be doing this year. And probably if I didn't have to give a technical talk, number one, I need more coffee. And number two, I think that would be what it would be on.
I'll go out on a limb and maybe embarrass myself, but it's by attributing the quote, I think it's Gibson. It's like the future is here. It's just not evenly distributed yet. And so, yeah, it'll be Well, I will be looking forward to watching that. I'm excited that this hypothetical talk is actually a very real one, and there's a series of them that'll be happening. Matt, non-technical talk, but if you had to give one that wasn't this one, which would it be?
Whew, man, non-technical. I'd probably go with how usability affected toy design in the 80s and center that around He-Man and She-Ra. Yeah.
Yeah, I caught the Netflix had a documentary series. I think it was called the Toys That Made Us, and very, very much. Oh, look at that!
Yeah.
Yes.
Wow.
Yeah, I enjoyed the trip back into portions of my own childhood when entertainment was mostly trying to trick me into buying bits of plastic.
I was always fascinated by how much, as a child, you don't realize how much corporate shenanigans are occurring between these toy companies and how brutal they got with each other. And then the woman who started Barbie, man, she was brutal. I was like, dang, she wanted to crush everybody. That was cool.
All right. Well, I'll let you get on to the much larger and more expensive toys for data center for everyone else. Thanks so much for joining us, and I will let you lead in and take it away for our last session here.
Cool. All right, let me get this going. Let's see if we can. Hopefully, let me know if you guys can see this. I really hope.
Had it for a second.
No, maybe.
It came up and then went away.
Okay. How about now?
Still your bright, shiny face there, Patrick.
Man, it's not like me today. Just so everybody knows, we did try this yesterday, and it did work. So this is one of those fun little bits. All right. How's this?
That works.
All right. If anybody doesn't mind, I'm not going to go put this into presentation mode because otherwise it seems like that killed it the last time. But anyway, I think just in terms of agenda, we discussed a little bit about what we want to talk about today. And really, I think there were maybe three big topics aside from the introductions, which I think we just did. There are a couple of kind of key megatrends that as we look forward past 2021, we're going to start seeing in the data center. And specifically, I had 5, but I think we cut it down to 3. And I think that the big ones that we're going to focus on today are rising TDPs in the data center and what that means really for kind of planning your deployments for data center operations beyond 2021, really into 2022, 2023, and beyond. Also, we're going to talk about DPUs and what I call bringing today's cloud tomorrow. And then finally, heterogeneous compute and the changing, system and data center design. So with that, I'm going to strategically skip over the next slide. I don't need it. But big things I want to talk about in terms of the rising TDP impact, key drivers for change, beyond just the fact that we're scaling cores, bifurcation data centers between liquid cooling, air cooling, and then just really, the fact that this is going to change is going to really impact a lot of folks. And Christopher, you guys, I don't think you've seen the slides. Maybe Matt, you haven't either. But I just kind of went and I did a little exercise where I just kind of looked at the rising core counts for x86 processors, both from Intel and AMD, since 2009 to 2011. And I think 2022 we're set for another pretty large jump from both vendors. But the big point here is just the fact that we had been on this this kind of nice little curve where we really had a pretty slow increase in terms of core counts for over a decade, really. And then over the last couple of years, we've really seen both, really driven by AMD's move with Rome into 64 cores and 128 threads per processor. We've really seen a pretty big increase, well above the historical trend line. And then, with this latest Ice Lake Xeon release that happened a couple weeks ago with Intel, we also saw a pretty good jump above the trend line there. And then, of course, we can't really talk about Sapphire Rapids and Genoa and future platforms, but we are going to see a pretty nice increase there as well. When we take a look at the ARM, we're going to talk about ARM, I think, a little bit later, but just in terms of how much bigger these ARM chips are getting. We looked at the ARM cores or ARM chips back in the day. We had Thunder X, which I think went up to 48 cores. Thunder X2 was a 32 core part. We had Graviton 60 cores. Late last year, we saw Ampere Ultra with 80 cores, and we'll have Ultra Max this year at 128 cores. I think that's all that's publicly announced. So we're going to go with 128 cores for 2021 right now. But of course, the ARM folks are looking, and the ARM ecosystem is looking even beyond 128 cores at this point. So big thing there is that ARM is going to end up being a net increase in terms of the overall core count, and significantly above that trend line that we had for years with Intel. And then the impact of that also is just the fact that we're also going well above the historical trend line in terms of TDP. So when we take a look at what the high TDP parts were, hopefully I didn't miss any, but even looking at the workstation parts, what have you, when you look at the high TDP parts in the sockets, you're going to see that we have gone from really kind of maybe that 130 range a couple of years ago, or about a decade ago, to now we're in that 270, 280 watt range for publicly available parts. In terms of GPUs, it's going to do something kind of similar, but realistically, it almost looked like it was like 2x this. So today, a NVIDIA A100 is a 500 to 600 watt TDP part when you're in an SXM4. And so it's about 2x what you see on the CPU side. But the big story there is just the fact that the overall CPU and accelerator markets, we're seeing a pretty significant shift to larger chips with also higher TDPs. And so I guess that kind of creates some challenges. And really those challenges are, well, how the heck do you cool higher TDP parts? And I think this is where I'm probably going to ask Christopher and Matt to maybe jump in. But one of the big trends that we're seeing is liquid becoming mainstream. And really, I think a lot of hyperscale folks are looking at liquid for next generations. Maybe open it up to Christopher. Maybe you could share a little bit about what you're seeing.
Sure. I think, and obviously, like everyone here, I've seen the non-public data, and I'm fully expecting, my next gen servers might be 350 TDP on the CPU, and an accelerator that might be, like you said, double that. And you start taking that, and you start putting then high-speed SerDes, DDR5, PCIe 5 into that, and you start putting a number of, say, E1 form factor rulers in front, which you can each draw theoretically 40 watts. It's not a unicorn server that might actually be driving. TDP is basically the power consumption mark. It's the power consumption of a chip, CPU or a GPU, how many watts it's consuming, and therefore how many watts of heat it's producing on the other end. So a TDP of 350 means that the CPU is consuming 350 watts of power and generating 350 watts of heat. But it's not a unicorn server that's going to be upwards north of 1,000 watts. It's going to be a normal AI enhanced compute node. Is going to be north of 1,000 watts, and getting that heat out of 1U or 1/2 wide 1U is going to be really, really interesting. So I think it's not we should be thinking about liquid sometime soon. We need to be thinking about liquid now, because I don't see any other way of reasonably evacuating the heat off of these platforms, unless you stick a jet engine in front of them. And I've got some further thinking on the liquid, but I guess to the man who works for the company that generates a good chunk of this heat in these servers, Matt,
comes from the software side. Yeah, so as far as I care about the heat, as long as it doesn't take down my software, I'm cool. But so speaking from position of NVIDIA, though, we are seeing this issue in our own data centers. We're seeing, just temperatures are just crazy high. And I don't work in this side of the business with the data centers at this level, so I don't want to talk about it too much, but we are adopting liquid cooling. We have to. There's just been some recent events that we've seen where our heating is just a little too much in those data centers.
Any puddles of silicon in the bottom of a server chassis yet? I think the thing that, and we talked about this a little bit before, as between a couple of us on this chat, is the interesting thing is if we go, there's two ways of doing the liquid cooling, right? One is to bathe everything in liquid, either in a tub-like scenario or maybe in a sealed module. The other is what you might want to call hybrid cooling, where you put evaporator plates on the CPU and the GPU to move the bulk of the heat, and you use air to cool the rest. My concern as we start looking at that,
on so we're seeing with air cooling, our RPMs are maxed out on all that. Like, we're not able to cool it enough with air in our data centers.
right? So that's what I was sort of saying. But even within the server, right, there are sort of two approaches to this, Patrick. And now, did you want to go into sort of hybrid versus? Was that? Am I stealing your thunder?
That's okay. Why don't I go through just real quick, just what I'm showing on the slide, though. That might help ground a couple folks in terms of what they're looking at. On the left side, we have something which is a pretty common bit where you're using water blocks to cool some of the key components. And it's actually the Lenovo Neptune unit. And so that's one idea where you would go and put basically a fairly standard server, put water blocks onto specific hot components. And then depending on the type of solution, you either would or would not have additional fans to cool some of the bits that are not being cooled by liquid. There's I guess a little bit of there are different design approaches, I'll just say, in terms of what folks are thinking there. Middle is a submer immersion tank. So that's really taking the entire server nodes and putting them into liquid. And the idea there is that you can efficiently remove heat from all the hot components, but you don't necessarily need to go in and do all the piping that you see on the left side with Neptune. Often you'll end up, a lot of these systems work where you'll actually have something in the rack, which is a loop within the rack that will go pull heat directly from the components, and that'll be one loop, and then there'll be a heat exchanger to a facility water loop as another good example. So there's a whole bunch of different ways that these things can actually be hooked up to data centers, but they do have a big impact in terms of design. And the third one on the right-hand side, I tried finding a sealed module, and the best one I could find, I think, was from Supercomputing 19, a Sugan server with CPUs and GPUs in it, where actually had sealed modules, and they're looking at that in terms of how they deliver their supercomputer designs. And so there you can see that the entire node is being submerged, but you do have the serviceability that you would kind of see more like a typical blade server. And then all of the liquid is exchanged through the rear of that chassis through quick release interconnects. So that was the best I could find that we had the ability to actually show because I took the photo. Just kind of talking about the kind of three main ways that we're seeing folks look at doing immersion cooling or liquid cooling. Sorry.
Yeah, I think the only point I was going to make here that I wanted to make here is that first one with the evaporator plates or the water blocks. It will be interesting to see as we drive things like the SerDes is higher and faster and therefore hotter. It's not just the CPU or the GPU that's heat's increasing. The RAM's heats is increasing. The storage, the E1S or whatever form factor you're using, that heat's going to be increasing as well. So even the SmartNIC. So once you put the plumbing in to cool the CPU and the GPU, is there enough space left to move enough air to cool all these other things that are now starting to approximate the heat of of last generation CPU, right? So it's going to be an interesting question if you can do the hybrid. Each compute node has some amount of water or liquid and air. Are we even going to be? Is that even a durable path or not? I think it's going to be an interesting question.
Yeah, and hey Matt, I know you can't say this, but I can say this because I don't work at NVIDIA. But in terms of as we're reviewing some of the big NVIDIA A100 SSM4 systems, such as the Dell PowerEdge XE8545. What you actually see is that there are now, when you have GPU servers, a lot of times there are guidelines in terms of what you can run your ambient temperature in your data center. And it's a lot different than, I guess, previous generations where that was less of a concern. Now to actually run just these systems, especially when you're at the 500-watt SXM4 modules, heat is a big concern, and you actually do need to keep certain data center temperatures just to be able to use the systems and not have them overheat. So it is becoming, and that is a 4 A100 system based on Redstone. So it's not even we have the Inspire 8 A100 system, and that of course requires a little more cooling even than that. So anyway, Matt, did you have any other thoughts on this one?
I don't know on this one. I'm waiting for DPUs.
Okay. But actually, Matt, let me ask that. I think. Do you concur that we are going to see a larger and larger percentage of compute workloads in the next 3 to 5 years will be AI? We'll need to have some form of AI acceleration, which sort of walks down this path.
Yes, I concur. Yeah. There's things I would concur. I'm parsing what I can say and what I can't say.
Of course.
Yeah.
I'll try to make sure that you don't say anything that I'll get yelled at if you say too. So I don't the NVIDIA PR folks coming after me. Hey, so just real quick, one of the big things that I just want folks that are, I guess, watching this to think about is really just what's the impact of having something like one of those immersion tanks in your data center. So if your data center is designed for being able to pull out a server on a vertically, being able to pull them out in a horizontal manner. If you remember that submarine immersion tank, it's a big tank, and you actually need things like infrastructure on the ceiling to be able to lift nodes out of the liquid and be able to even service them. So and things like facility water were not necessarily, I guess, commonplace in older data centers. This particular data center is actually the old Yahoo Level 3 data center in Sunnyvale that we had our first data center lab in. It looks a little different than it looks like today. And interesting note, if you were to go look to the left of that Dell server that's being installed, kind of way back in that room, would actually be where a packet cage is. So fun little tie-in there. All right, let's get to DPUs, because I think that's that's kind of what Matt wants to talk about. Here I just had a couple thoughts. First, just in terms of AWS Nitro really kind of kicking off this effort in the industry. There have been other efforts, but to me, that's the one that was really kind of pushing folks. Talk a little bit about what the heck is a DPU, and then also quick discussion of different types of NICs. So really the difference between an offload smart NIC, a DPU, and then something I'm calling exotic because I don't really have a great term for it. And then really just kind of how it changes the relationship between the infrastructure layer and the application layer. So I'm gonna just flip. Does anybody want to do this? I can do it. Just talking about what AWS is doing with Nitro.
All yours, Pat.
Yeah.
All right.
Yeah.
Cool. Yeah, I can understand why. So hey, so for folks that don't know, when you go and provision or how AWS manages their infrastructure, and they had this idea many years ago, so you can actually see the AWS custom silicon going back to 2013 with Nitro 1. The basic idea that AWS has as a challenge is really trying to figure out how do we put a whole bunch of, I'm not gonna say random folks, but a whole bunch of different customers with different running different workloads and different security needs onto a common set of hardware. And I think one of the ways that they really innovated there was they thought about, okay, well, what if we were to separate that application layer with the infrastructure layer? And specifically what they're using for that is basically this idea of AWS Nitro. And I have something, which is a picture on the right-hand side that I kind of cobbled together from a couple different images in a video. But what that is actually a Apple Mac Mini, which is not necessarily designed with a baseboard management controller and all the features that you normally see in a server. Yet you can actually go and access them in the AWS cloud because they hook them up to the Nitro infrastructure, and you can see the Nitro card. I don't know if you can see my cursor, but the this kind of bottom card right here is actually the AWS Nitro card. You can see a little Annapurna Labs logo there. And basically the idea is that using these Nitro cards, and that really being the layer that the infrastructure provider, in this case AWS, interacts with the underlying hardware, that really helps create that delineation between what is the secure infrastructure and what the provider is responsible for, and then the workloads that are actually run on the machines, which is what you can have customers for. And of course, you could potentially have nefarious customers that are up to no good. Mm-hmm. So keeping your overall customers safe and also your infrastructure safe is a big consideration. And so hence, this is the way that AWS really solved the problem, and that kind of has moved out in the industry, I guess, and that is one of the big drivers of the DPU. Let me just ask, Matt, does that make sense?
It does. I would say it's one driver for a DPU, right? Some of the stuff so what we're thinking about here is, how do we isolate within shared infrastructure? And that's one of the use cases that we've been looking at with DPUs. So like secure bastions. But some of the more practical stuff that we've been looking at. So one, we're building chips, right? So we build technology, and then others take that technology and then figure out new uses for it, like innovate on top of it. With our own innovations, we're looking at things like VNF. Being on top of the DPU, offloading proxies to the DPU. So you can imagine offloading Envoy proxy to a DPU. But to be able to adopt these things, what we've been focused on is also just coupling it with our Docker framework, which is how set of standard libraries of how you're going to build your software on top of these DPUs.
Great, Christopher. Anything to add?
Yeah, so I think definitely offload of things like Envoy proxies and for a service mesh is definitely something that's interesting. I think even more generally offloading a lot of the networking down to a DPU. If you think, for example, like a Calico or something along those lines, running possibly on the DPU instead of on the main system, which gives you also a security enclave, because then theoretically the network security processing can be done under a separate control plane than the main system.
Interestingly, we discussed Calico, offloading Calico onto the DPU as well.
Yes, side. I think we've talked about that, you and I, before in the past. But yes, that's certainly one. I think another one that's interesting is using this for things that are primarily going to be destined for not host. So let's say you've done a distributed storage system, say based on Ceph or something along those lines. Most of those transactions, if it's a distributed storage system, aren't terminating on that same host, right? It's basically distributed storage. A little bit of storage comes from a lot of places. Then do you run those things like the OSDs, the processes that manage the storage units themselves and do the write and the reads, et cetera? Do you run that on the cores, or do you run that in a DPU, which is also directly connected to the network? So basically you have almost a storage system that ships in the night to the node that's physically hosting it. It is another interesting use case. So I think there's quite a few things that you can use or misuse a DPU for fun and profit.
And within storage, things like storage federation can be done now. Putting NVMe drives on Bluefield cards.
So the question, when I think about that, Matt, I'm thinking you can do that. You could also, obviously, since some of those cards have PCIe roots, you could actually still use an E1 series infrastructure in front, but wire those NVMEs directly, or logically directly to the DPU rather than through the main processor as well, which is also sort of interesting.
Yeah.
I think we started getting onto this slide, but the DPU is a term that I think we're using, and we're starting to adopt. I know Intel wants to call it something else, but I've been pushing back and telling them that they're not going to get marketing from us if they do change the term on me. But it literally came down to that conversation actually. But I want to just talk a little bit about what is a DPU, and actually it'd be kind of cool. Actually, Matt, what I did here is I just kind of put a Mellanox Bluefield 2. This is the 5 gig Ethernet version of it. Up there as our DPU example, SmartNIC. We have a Xilinx Alveo offload NIC. that's a ConnectX 6 200 gig Ethernet card. Exotic is basically my bucket for some of the more
new things.
Some of the more interesting designs that don't necessarily fit in the other buckets, but are pretty complex, that kind of fall into the space. And then also just simple NIC. The reason I have NA there is just because, at the higher network speeds, it turns out that just doing things on CPU cores basically doesn't work anymore. So a lot of the old simple NIC models that we used to have just kind of that model kind of just doesn't scale to the higher networking speeds. So as we kind of move up, I don't really think that the kind of lower end NIC model is going to be one that we see a lot. And so one thing I did do though was I did look at all of the available DPUs that are on the market from companies like Pensando, Fungible, Bell, Broadcom, NVIDIA, et cetera. And I kind of just said, okay, well, when people market a DPU, what are the common characteristics? So usually high-speed networking connectivity, you don't really see DPUs targeting the 1 and 10 gig Ethernet market these days. Usually you have high-speed packet processing with specific acceleration and programmable logic. Usually CPU cores, the vast majority of them are ARM cores these days. Memory controllers that are on board, accelerators. These days you see PCIe Gen 4 in this generation, but typically those can run either as root or as endpoints. So if you want to do things like have NVMe attached storage, you can do that and use the DPU as your PCIe root. And then security management features, and also you're generally running your OS separate from the host system. Matt, that was kind of my stab at this. Want to see what you think.
Did you? I clipped out right when you said my name, I think.
Oh, sorry. Yeah. I just wanted to see. This is generally aligned with how you think of things.
Yeah. In general, yes. I mean, I think we summarize it simply as system on chip. Is how we would say it. And then we break it down to pretty much the bullet points that you listed out. I almost feel like some of the bullet points might have came from our site with some of that, but yeah, I mean, yes, that pretty much syncs with what we're saying on our side. But I think if you were to just putting my NVIDIA hat on, we would say we have the first true DPU.
What's a DPU?
I think we just defined a lot of that in the last definition, but we could say it system on chip. So we have high performance programmable, multi-core, high performance network interface. We're capable of parsing high amounts of data, processing efficiently, transferring that with our data line rate. Rich set of flexible, programmable acceleration engines that we can drop onto these DPUs as well. That's how we would define it. So we have extra things that we can put on these DPUs. So I would, if you want to go check out DOCA, you can see how we're extending the DPU. But we think that if you just don't have the DPU, you have to have frameworks around it to actually do something with it, to ship something with it.
Well, actually, we have the Bluefield 2 DPU. I guess best slide I could find from NVIDIA on that. So, are there any bits that you want to talk about specifically on Bluefield 2?
I'm not comfortable probably talking about some of the stuff that we've been discussing internally.
Okay.
I don't know what's public and what's not public right now in my head.
Okay. Christopher, do you have any thoughts that you want to add?
Unfortunately, I think because I don't know where the line's drawn at this point in the conversations I've been having with a company also represented here, I'm probably going to take a pass as well, because at this point I don't remember what's public and what's not public. I do think in general, the way I look at these is these are platforms that are going to offload, are going to take what I view as sort of base level capabilities or accelerate capabilities and move them off of the compute complexes, where I can actually then do more, quote unquote, revenue generating work on the compute complexes. and I leave the DPU to do things like, eventually storage, networking, housekeeping in the background, offload of service meshes and that kind of stuff. So anything but to me, what's interesting here is to be able to run a real kernel and run real code. I don't want to have to refactor, say, Ceph's OSD daemons to run in some, non-Linux enabled DPU, right? Mm-hmm. So for me, it's interesting to be able to take existing code and deploy it on that rather than do a refactor or get somebody to write specific microcode to do something. So that is also potentially useful, but that is in and of itself a friction point. I would prefer to be able to deploy,
So one thing that's public, I think, on this, which I just confirmed, which is the Checkpoint partnership with shipping Checkpoint on top of DPUs, on top of Bluefield. And that's one example from the industry where this is being put out there into use, versus like Exotic, like coming up with ideas like what could the future look like. The future is right now, signing partnerships with organizations putting, shipping their code onto the DPU. And then working with them to do that.
And I'm just going to make a little plug here. So I got this actually, it's a little 25 gig Bluefield 2 DPU is the first one that I managed to purchase. We also have, I think, maybe 8 or so of the dual 100 gig models that have a little bit more memory and power behind them. By far, one of the coolest things, if you're looking for a project to go, learn about, this is by far one of my favorite things to just kind of tinker with on the side. So we're going to be doing some content around Bluefield 2 and just kind of what it looks like, because they actually do run their own Linux operating system. So it is kind of cool to have like a little, it is kind of cool to have a little Linux OS with stuff that's manageable out of band on your NIC. So certainly, they're actually available now. They were a little harder to get, I think, last year, but now you can actually just go buy them. So if you do want something to go tinker with, this would be one of my recommendations right now. Any other bits before we kind of keep moving? I know we only have 4 minutes.
Nope.
All right. Last one I just want to talk about, is really heterogeneous compute. There's a lot of changes that I think are going to happen in 2022, 2023. One of the big ones is CXL. And for folks that don't necessarily know, there's a cache coherent interface that's going to be coming to the next generation of processors and is going to enable a whole bunch of really kind of cool models and really fundamental system design changes over the next few years. Christopher, Matt, do either of you want to kind of jump in on CXL?
I'm going to pass on this one.
Okay.
Chicken.
Let Chris talk.
I think, one of the things as we start, and I understand why you're taking a pass on this, but I think higher speed interconnect, which by the way is going to drive TDP up. And going back to the original conversation, the faster you run stuff, the hotter they get, the more power they draw. But if we start talking about a lot of workloads potentially benefiting from co-processing, we're going back to the days before floating point was not in a CPU and you had to have a floating point coprocessor. Now we're talking about inference engines, and Apple's put them on chip, and other people are working on other interesting architectures that may have been recently announced. But if we're saying that a lot of our workloads now are going to need to process a lot of data and use accelerators or adjunct processors to do that, continuing to use the PCI bus, no matter how fast it gets, it is probably not the most optimal way of doing it. So having a higher speed bus that allows you to connect other things at very low latency to the main processor cores, either another processor or co-processors, et cetera, I think is it becomes a necessity. So I think this is one, and again, this goes back to the question I asked Matt earlier was, do we all believe that going forward, things like AI becomes much more mainstream in the way we write code and process data or not? And if it does, then we need a better, more efficient, lower latency way of getting that data back and forth between the AI ML engines and the main CPUs and the memory and everything else, right? That whole thing has to be tied together much more tightly than it is today.
Yeah, on the software side of our business, we're layering AI everywhere. I think how NVIDIA would like to probably position it, how we are trying to position ourselves is we are the AI company. We are a software company that's building on top of our hardware. So if you see announcements like Morpheus, which was the security announcement that we did, where we're doing real-time inspection of all packets looking for security problems. Yeah, we're gonna have some motors here as we introduce AI into these environments.
Cool.
But maybe we'll use AI to help us figure out how to fix these things too.
Hopefully one of these days.
Yeah.
Hey, so I know we're kind of running close on time, but just real quick, one of the other big things on heterogeneous compute is that everybody's looking now at tile-based or some sort of integrating smaller bits of IP into larger packages. I specifically chose non-NVIDIA ones here just to kind of make sure we had a little diversity. But just in terms of, Intel's even looking at this down to the desktop PCs, not just in the server world, but then when you get to the server space, that's Ponte Vecchio with 47 tiles on it. And, AMD, probably a little less intricate integration, but, they really moved from that monolithic die to, 4 dies and now 9 dies on a package. And of course, NVIDIA is already doing multi-chip packaging with their memory and their main compute dies. So something that's just we're gonna see more of in the future. I think the monolithic dies we're gonna see them a lot less, and we're gonna start seeing co-packaging of different IPs from different sources. But I do want to get to Rise of ARM real quick, which is just the fact that on the left side we have the Thunder X and Thunder X2, which are kind of some of the early ARM server processors. We had Graviton. I think it was a big milestone in the industry, and then now Ampere Ultra, and then soon Ultra Max. Processors that I think are really kind of driving that core count. They're driving some different capabilities and also driving different economics to get per core performance. Want to see if you or Christopher have thoughts on that.
Okay, this is definitely an area where I probably don't want to talk too much about ARM.
Okay, I'll wade in on this one.
Yes, Chris, you weigh on this one.
I'll take the pressure off of Matt. I think the interesting thing here that is maybe a little independent of what you were talking about, Patrick, is if I'm running monolithic apps that have been compiled, or I've built VMs that assume x86, I think those things still will drive x86. If we start thinking about more of a container world where things are composed or even compiled, but definitely at least composed on the fly, say, your pod spec hits cube and the kubelet on a given host says, okay, I've got to build this, and it's running on ARM, it's going to go grab the ARM bits or do the ARM build. If it's on an x86, it's going to do the same thing. So all of a sudden, what system you're running on is a lot less important than it was in the days of VM gold master images and compiled monolithic slabs. So then you start looking at the same thing we were talking about earlier, TDP. What's TDP doing? I get TDP on ARM is somewhat better than TDP on x86. There's a lot of benefits to the way the ARM has been done for that kind of environment. So what I honestly expect to see is this trend to continue or even accelerate as people start adopting more open source based, container based workloads and application design patterns. The x86 being the only viable option, sort of that catch sort of falls away, and now it becomes an honest foot race between ARM and the x86 architecture as to what is best fit for purpose. So I honestly think if you're not thinking you're going to have heterogeneous data center in the next couple of years, you're probably incorrect. I think this is this is not a oh, this is a cool toy and it's going to disappear in a little bit. No, this is here to stay.
Cool. And you can go put a little mini ARM server into your existing server if you get a Bluetooth 2 NIC. So
Exactly.
DPU. So there you go.
Well, and ARM dovetails into DPUs as well.
Yep.
Yeah. So cool. Well, that's kind of all I had, and I think we're already a couple minutes over, so probably gonna get in trouble for this one. But I'm gonna open it up. Do we have any closing thoughts or questions from folks?
Jeremy, you're muted.
Of course I'm muted. Big trouble. We'll see if additional questions come in from chat. But first off, thanks so much. I'm both excited about the future and a little bit worried about the coolant mess. But I guess it's like serve the home's not necessarily my home, and so there may be not for everybody else, but for smaller data centers.
The things I see every day coming into work. So I'm fairly new to NVIDIA. I came in January. Every day is like walking into the future, really. You see, we have DPUs that we're working on. We have Grace, that was announced. We have, and I live in the cloud business unit where we're focused on software, delivering software services. So things like 3D universes. So like Omniverse as a universe that you can log into and engage with. It's amazing, and then what's crazy to me is thinking about where all the touch points for AI and like, what do we mean when we say AI, and so if you look at some of our work where we did like that first digital twin of a BMW factory, where we're able to combine robotics, AI, and humans together in one location to keep everyone safe, and all that stuff. So that's I think what's amazing about all these technologies kind of coming together. But it can sometimes feel like a Black Mirror episode at times too.
Yeah, we'll certainly do what's inside your power to use it for good, if at all possible.
Yeah, like deep learning with some of the Pfizer research.
Yeah, I've got Pfizer coursing through my veins. So thank you for whatever part you had.
I'm also in the Pfizer club, so going out there.
In the Pfizer clubs here.
Yeah, I'm in the other club. I'm in the Moderna club. So
Still counts.
Still counts. In fact, I get my second one in a couple of hours. So,
well, definitely you won't be in work tomorrow, I guess.
Probably not.
Yeah. But yeah,
well, may the force be with you then, since today is like Star Wars Day. So hopefully you'll be powered up, and we'll soon have your superhero powers.
There we go.
And yeah, enjoy the immunity and hopefully a nice long nap. Christopher, Patrick, Matt, thanks so much for joining us to close out Giphy Day.
Thanks for having us. It was a blast.
Thank you. Bye-bye.
Cheers.
Awesome. Well, yeah, that was a lot of like good and also tantalizing and top secret stuff. I feel like I was just like debriefed on the future of data centers or something, and at any moment some cyborg will come down from space and be like, you know too much, and take me away.
Hopefully not.
I mean, depending on where they're taking me, I might be willing to go.
Fair. But yeah, thanks so much for joining us, Metalheads. I guess that'll be the end of Google Infrastructure for Everybody Else Day for 2021. Maybe we revisit it in 2026 if Grace hasn't been abducted by aliens.
That's right.
But that's not the end of content. Please skip back to enjoy the rest of 3 more days of KubeCon Europe, and so there will be plenty more to catch. Continue the conversation in the chat, in Slack, slack.equinixmetal.com, Twitter, just @equinixmetal, and that should be the extent of what we have for you. Any closing comments?
I just hope to see everyone online. I've been trying to tweet while the sessions have been going, so please tweet at me, Twitter at me. I don't really know what the correct verb here is, but I'd love to hear from everybody and continue the conversation.
Excellent. Thanks so much. We'll see you later, Metalheads.
Bye, everyone.